Hello, everyone. Thanks. Yeah, my name is Christian. I am a principal solutions architect with AWS, and I have the pleasure to co-present today with Celine Rowan-Winter from BMW. The last 18 months, I was working closely with BMW Software Development Platform team, which is part of BMW's Software Factory. And during this time, we architected a hybrid solution for BMW's software development platform, which takes BMW's requirements in terms of current and future scale reliability and also cost efficiency into account. And that's what I would like to share with you today, putting the focus on cost optimization. Before we go into the details, Celine will explain why software development is so important in the automotive industry these days, and will also introduce BMW's software development platform, which is called CodeCraft internally. For the majority of this presentation, I will dive into the learnings and the success and share this with you before Celine will then finish with the business results we could achieve.
Hello, and thanks for joining. I am Celine, and as the Vice President of Connected Vehicle Platforms at the BMW Group, I'm responsible for a team that delivers premium and innovative connected drive services. This is only possible with the perfect interplay between the functions inside the car, like the entertainment system, and our backend services running in AWS. Let's talk a little bit more about why software development is so important in the automotive these days. A modern car contains hundreds of smaller and larger electronic control units. The trend is going to a so-called domain architecture, where functions are collocated by their domain. For example, the lane keep assist and the adaptive cruise control are part of the automated driving domain. And all these high-performing electronic control units are communicating with each other via a vehicle network and a central gateway. This means that a modern vehicle like the BMW Series 7 contains more than 500 million lines of code developed by internal and external software developers to one of the most complex products. And just imagine the variety of models BMW offers and the markets that we are delivering in, which could also mean different softwares, for example, for automated driving functions in the UK and in New Zealand, because we're driving on the left side. So that's why we developed quite early our award-winning platform, CodeCraft. CodeCraft is containing a lot of tools and servicing that you would assume for such kind of developer platforms. Things like a code repository, an artifact repository, CI pipeline, issue tracker, and so on. And our platform used to be on premises, but with the success of the platform, we were facing a lot of scaling challenges. That's why we talked to AWS to plan the expansion of CodeCraft on AWS. So let's take a look at these challenges. We have more than 2,000 developers working with CodeCraft. 165,000 daily builds and 5,500 builds running concurrently in parallel, which means that we are using concurrently 85,000 virtual CPUs. That's a lot. And the teams are focusing on three major major critical success. First of all, the reliability, then the business impact, which translates to developers' productivity and the cost efficiency. And with the success of the platform and all developers wanted to use this, we were facing really big deals with the reliability. The developers' productivity also went down because a lot of CI jobs couldn't get executed, were waiting into the pipeline, and we really faced some big challenges in scaling. And last but not least, trying to scale cost efficiently on premises is really almost not possible. That's why we reach out to AWS, and Christian is going to explain this to us.
Thank you, Celine. Yeah, let me start with a quick introduction of the overall architecture. Because not all resources BMW was using on-premises reached end of life. And this was the reason why we designed a hybrid solution which allows BMW to move dedicated workloads to AWS as needed. And first, we established a robust network infrastructure before we then moved or replicated core services like GitHub and Artifactory, as well as zonal services like Build Barn and Soul CI to AWS. And this was just a prerequisite to run the first builds in AWS. And over the last 15 months, we migrated the majority of infrastructure and CI jobs to AWS. And this is what you can see in orange on the right. And over the next 12 months, we will move the remaining CI jobs to AWS as these resources also reach end of life on premises. But let's talk about the biggest improvement and the learnings with this migration to AWS. So one of the low-hanging fruits, of course, was to move to the latest and greatest EC2 instance generation as fast as possible. So for example, when we moved CodeCraft's GitHub repository from an M6 instance or M6A instance family to the newer generation M7A instance family, CodeCraft could measure a reduced average and peak latency for Git push and Git clone operations. Another question we ask ourselves from the beginning is, are all these EC2 instances right-sized BMW is running for their CI job? And you have to understand that each of these 165,000 CI jobs BMW is running daily is running on a new provisioned EC2 instance to prevent side effects between builds in a multi-tenant environment. And each of these CI jobs can be as small as running a linting job just for a couple of minutes on a 2 vCPU machine, but it could be also building a large infotainment system running for a couple hours on a 192 vCPU machine. Normally in AWS, you would use Compute Optimizer just to get right-sizing recommendations for your EC2 instance. But because these jobs are only running for up to a couple hours, you will not get these right-sizing recommendations from Compute Optimizer. So the team has to come up with their own solution. And CodeCraft adapted Systat, which is an open source Linux utility which allows you to collect all kinds of operating system metrics like CPU and memory utilization, network and I/O usage, and many more. And CodeCraft put Systat into their base EC2 Amazon machine image they use for running their builds. And Systat generates a metric file which is uploaded to S3 at the end of every CI job. And then this metric file gets analyzed and visualized automatically, which provides insights to the platform team, but also to the internal teams whether a specific CI job was running on a right-sized EC2 instance or not. In addition, the team is also collecting metrics about the duration of a given CI job. And this makes it quite easy to also benchmark different CPU vendors and architectures against each other. So an AMD CPU against an Intel against an Amazon Graviton. And we measured quite significant differences depending on the build and depending on the CPU vendor. Codecraft containerized their core and zonal services and selected Amazon EC2 to run on AWS. They also initially decided to use a traditional Kubernetes cluster autoscaler to adjust the compute instance based on varying demand. And in March this year, the team decided to move to Karpenter, a flexible Kubernetes cluster autoscaler where AWS initialized this open source project. And by moving to Karpenter, the team could achieve an AWS infrastructure cost reduction for up to 66%. And there are two main reasons. One reason is Karpenter constantly optimizes the utilization of your EC2 instances and moves container between these instances. And Karpenter also provisions right-sized EC2 instances and terminates EC2 instances which are not longer needed. And this is how Codecraft could achieve a very high utilization of their EC2 instance of almost 94%. A second reason is Karpenter integrates with EC2 Spot very well. And this makes it possible for you to use unused EC2 capacity with a discount of up to 90% compared to on-demand. And let me give you just a quick refresh on EC2 Spot. Spot instances are not different than on-demand instances or reserved instances. It's just unused EC2 capacity we make available to you with a discount of up to 90% compared to on-demand instances. There's also, or you have to consider that if on-demand needs additional capacity, we may reclaim this instance from you. We send you an interruption notice, and 2 minutes later, we will terminate and reclaim this instance. And therefore, it's important that you diversify your Spot fleet, which means using multiple instance types. So what does this mean? If you, for example, take our C7i instance type, each instance size in each availability zone, in every AWS region, is a separate Spot pool. And if you can run your workload, for example, on any of these 10 instance families, and let's say you can run it on an extra large and large instance size, in 3 regions, in 3 availability zones, you tap into 190 different Spot pools, which reduces the likelihood that you will experience a Spot reclaim. So, when Codecraft adopted Spot, they're leveraging SoulCI, that's their CI tool of choice. SoulCI is using the EC2 Run Instance API to request or to launch a single instance. And my colleagues and me, we are providing some hints to BMW which instance type they should use to see the lowest amount of Spot reclaims based on the visibility we have in our Spot pool. But this is, of course, not a scalable solution, and this can also change every day. And therefore, we sit together with the Codecraft team and decided to move to EC2 Fleet. And with EC2 Fleet, Codecraft is still launching single EC2 instances, but EC2 Fleet allows you to provide a list of EC2 instance types which are capable of running your workload. And this is how it looks like. First, you define an allocation strategy, and we started with a capacity optimized, which means AWS selects EC2 instance type which is least likely to be reclaimed. Then you configure a launch template and give it a name. And the most important part is here, where we initially selected 11 different instance types which are capable of running this workload. And last but not least, you also provide a target capacity and capacity type, which was Spot in our case. We contributed these changes to the upstream open source project, SoulCI, so that everyone who is using SoulCI on AWS can leverage these features now. And this is a screenshot of BMW's FinOps tool. And if you take a look here at the table at the bottom, you can see that in January 2023, BMW was only, Codecraft was only leveraging about 2% of Spot. But now in October 2024, Spot usage increased to 44%. And this is also the reason why Codecraft now can save a quite large six-digit dollar amount every month just by using Spot instances. But not everything was as shiny as we expected it. So the Codecraft team also experienced many more Spot reclaims than we initially expected. And while still benefiting from the large cost savings by using Spot, a reclaim means this CI build gets rescheduled on a new instance and will finish eventually. But this developer who pushed this change experienced a longer delay until he gets feedback. And this can be translated in a reduced developer productivity. And that's exactly the opposite of what we want to achieve. So, one tool AWS recommends is the Spot placement score tracker to get a better understanding or an objective view what you can expect. And it measures or it collects the Spot placement score, which is a metric which tells you how likely it is that your Spot request will succeed, and stores this metric in CloudWatch. And it does this continuously for all your EC2 fleet configurations, so that you at the end have a dashboard which provides to you an objective view what your experience will most likely look like by using EC2 fleet with your fleet configurations. In addition, we are using the EC2 instance selector. This is a CLI tool which allows you to specify your compute requirements in terms of CPU, memory, CPU architecture, and many, many more. And what you get back as a result is a list of instance types which all matches your requirements. And I have highlighted here all the 11 instance types we have selected initially. And when I cross out all the instances which have burst capacity, because we need constant performance, you can see there are quite a long list of instance types we could use, but we didn't configure yet. And with this learning, we went back to our initial EC2 fleet configuration and added these 20 instance types. And with this, we tripled the Spot pools we are tapped into. So we are now leveraging 300 Spot pools. And in addition, we also changed the allocation strategy, moving to the price capacity optimized, which means AWS will select the instance type from within the Spot pool, the cheapest instance type from within the Spot pool with the least likelihood of seeing reclaims. And with this, we could already decrease the number of Spot reclaims we have seen in the past, and we have a couple more changes in our pipeline where we believe it will further reduce Spot reclaims. And with this, I would like to hand over to Celine for the business results.
Okay, Since the very beginning, the code craft team has been measuring their customers' satisfaction, the developers. And since we are using AWS, the customer satisfaction score has been constantly increasing. And there was not one single disruption. The Automotive IT Congress awarded CodeCraft in the category Business Impact, as we are not able to scale the CI jobs when needed, and also shorten the response time between a code push and the feedback to the engineer. The developer's productivity increased, which means also better business impact and faster time to market, which is one of our main goals. And last but not least, cost efficiency. We reduced the cost of our overall platform, but more importantly, the cost per CI jobs. And the job is not done. Since we are increasing the workload on the platform, we still have to work a lot on scaling cost efficiently and contribute this way to a more sustainable future. Thank you.
Thank you very much. And we would really appreciate if you take the 1 minute and rate our session. If you have any questions, we're happy to answer questions, so we will hang around a little bit longer.